This is Algebra 2, notes for the final review. We're going to go ahead and start with Unit 2. I want to list some of the formulas that we used in Unit 2. Some of the ones were the slope formula, y2 over y1 all over x2 minus x1, slope-intercept form, which is referred to as y equals mx plus b. M is the slope, and b is the y-intercept. Most of us should know that one pretty good. And the other one that people tend to forget is point slope. And this is the one that we use to actually write equations most of the time, and that's y minus y1 equals m times x minus x1. We substitute for this y and this x with one coordinate point. Okay, so let's go ahead and do a few of these. So looking at a real basic one, if you wanted to graph a line that went through a particular point, so for example, I need to graph a line. So I need an equation to do this. I want to do it by creating an equation, then graphing a line. And they give me the points 2, 1, and the points. Actually, sorry, I want to do the points 2, negative 2, 2, and 4, 3. So the first thing I'm going to do is I'm going to find the slope, and I'm going to say, okay, 3 minus 2 all over 4 minus negative 2. And that's going to equal 1 over 6. Okay. So now I have a line, or I have a slope. Okay, and then now I need is a point on that slope to actually write or to draw the line. So now I need to pick a point and use my point slope form up here, right? So I'm going to go ahead and pick this one, and I'm going to say y minus the y coordinate equals 1/6 times x minus the x coordinate, and it's negative 2, so it's going to be plus 2. Okay. And then I would go ahead and distribute and solve from there. Solve for y. Okay. Let's look at finding slope and y-intercept. If I give you an equation like this and I wanted to know what's the slope, okay, the slope is the value always in front of the x. So the slope would be 5. The b, or in other words the y-intercept, okay, is negative 1/2. We want to find those pieces of information. What if we wanted to graph an equation like that? Okay. So if I gave you y equals 1/3 x minus 2, and I wanted to graph that thing, remembering how to use y equals mx plus b. Okay. So you'd start from negative 2 on the y-axis because your b is negative 2. You'd go up 1 space and go over 3 spaces using your slope, which is n, which is 1 over 3, and that's a reference to rise over run, and then there's your line. And there's your line. Remember that for this to work, y must be by itself. So you may actually have to solve for y to work that out. Another thing that we're going to have to be able to do is find x intercepts and y intercepts. Okay. And the big thing you want to remember when it comes to x and y intercepts is you always remember, make the other one 0. So if I gave you something like this, I said find the x-intercept. Well, to find the x-intercept, I'd have to make the y 0 And to find the y-intercept, I'd have to make the x 0. Please don't make the mistake of making the same one 0 when you're trying to solve for it. So over here, I'm going to plug in a 0 for the y. Okay, and so my x-intercept is 8. That's actually a coordinate point, 8, 0. Over here, I'm going to plug in a 0 for the x. I'm trying to find the y. You can see that's just 0, so I'll divide by 4, and y equals 2, and then this is the coordinate point 0, 2. My y coordinate, because that's if I want to find x and y intercepts. Okay. Another thing that we have to do that's in this unit is systems of equalities and inequalities. So if you remember, for example, if I had something like I have to solve for x and y, I'm going to get y equals 9 minus x, and if I give you 5x minus y equals 3. This is where I can use substitution or elimination. So I'll do one of each. This one's set up really nice for substitution because this y is isolated. So what I'm going to do is I'm going to take this, I'm going to plug it into this y right here by using the substitution property because it's equal to y. So my new equation is 5 minus 9 minus x equals 3. I have to distribute this negative, equals 3, and then I'm looking at basically 6x minus 9 equals 3. I'm going to add 9 to both sides, and I'm looking at 6x equals 12 divided by 6, and x equals 2. So once I do that, now I got to go back in and plug in for the other value, for the y value. So it doesn't matter which one you plug into. I'm going to plug into this, go back to this one up here and plug it in right there. So I'll kind of do that right here. I'm going to say y equals 9 minus my 2, and then y equals 7. And remember, this is actually a coordinate point, so the answer is 2, 7. The actual answer is 2, 7. Let's do one using elimination. And we're looking at 8x plus 5y equals negative 13 over 3x minus 2y equals negative 1. And elimination is where we cross them off, so you got to make them the same. You pick one you want to get rid of. I'm going to get rid of y's just because they're already opposite signs. So I'm going to say what's the least common multiple for 5 and 2, and that's going to be 10. So I'm going to multiply this one by positive 2 and this one by positive 5. And so now I'm going to rewrite these as 16x plus 10y equals negative 26. And then down below I'm looking at 15x minus 10y equals negative 5. Okay. And those cross off when I actually add the equations. I'm looking at 31x equals negative 31 divided by 31, and x equals negative 1. Now looking at this, I need to go back and plug in, kind of squeeze that over here, and I'll just plug into this bottom one right here. So I'm saying 3 times negative 1 minus 2y equals negative 1. It gives me negative 3 minus 2y equals negative 1. I'm going to add 3y to both sides, and that gives me positive 2. I'm going to divide by negative 1, and y equals negative 1. So the actual answer to this one is negative 1, negative 1. That was our substitution elimination. When it came to inequalities, you really can't solve them that way because there's more than one answer. And what I mean by that is questions like this. If I gave you something like y is greater than or equal to negative 2x, and 2x minus y is greater than or equal to 1, when looking at this, I need to graph these. And this one's not really set up to be graphed. I'm going to set it up using y equals mx plus b, or an equivalent, because it's really not going to be equal because it is an inequality, but it can still act like it. And then divide by -1. And I just divided by -1, so the inequality sign does switch. Okay. And I'm just going to kind of box these to make sure I keep track of which two equations I'm using. This one here, if it helps you, you want to think of this as +0. So I'm actually going to box that one. Right. So when I actually graph these, okay, let's start with this one. This one has a y-intercept of 0, and it goes down 2 spaces over 1 space. This has it's or equals 2, so this is a solid line. Okay, and it says the y's are greater than the line, so that means I'm going to shade basically up here above the line where the y's are greater. Now I'm going to kind of ignore what I just did and graph this one. This one has a y-intercept of -1. It has a slope of +2 over 1, and this also is a solid line. Okay. And this is where the y's are less than, so that's underneath here. Okay. So if I wanted to kind of highlight where the actual solution is, it's the overlapping shaded regions, and it's basically everything, you know, in this region is a viable solution. Okay. Let's go ahead and take a look at some stuff from Unit 3. A lot of this was factoring that we have been reviewing in the previous unit, so we don't really need to spend too much time on the factoring techniques. But I want to talk about some of the negative power stuff. For example, remember what negative powers equal. Okay, that equals 1 to the x. And so to kind of look at some trickier type situations, if I have 3x to the -1 to the -2 all over x, well, what this actually equals is, you can bring in the power or distribute the power, whatever you want to do. So I'm going to actually multiply this power in. Okay, now you're multiplying these, so it's 3 to the -2, x to the +2 all over x. Now this x drops down, and the answer is x squared all over 9x, and then we can reduce the x's, and the answer is x over 9. Looking at another question with some negative powers. If I had something like 6x y to the -2 all over 10x squared y squared to the 5th, sorry, and all that raised to the -1. Now everything gets a negative power, including the constants or the numbers. So it's 6 to the -1, y to the -1, y to the +2. I'm multiplying this to everything. 10 to the -1, x to the -2, y to the -5. Okay. Now I got it. Remember, negative powers are going to switch sides, so they're going to be reciprocals basically. So we're looking at this. 10 moves up, 6 comes down, this x comes down, these two x's go up. This y is a positive power, so it stays there. So I got y2 times y5. Okay. And then I'm going to go ahead and start reducing here, so I can take a 2 out of both of these. That leaves me with a 5 over a 3. I can cross that out, leaves me with an x, and those two y's multiply. So I'm basically looking at 5x y to the 7th all over 3. Okay. Another thing that's in there that people tend to forget how to do is dividing polynomials. 2x plus 3 all over 4x to the third plus 8x squared minus 7x plus 1. Now looking at this, remember how this works. You always got to see what do you have to multiply this by to turn it into that term. Alright, so I got to, and then you put it over the same power, and I'll show you what I'm talking about here in a second. So I would have to multiply this by 2x squared, and since it's an x squared, it goes over that one. Now I have to distribute that into this, and I'm looking at 4x to the third plus 6x squared. Then I have to subtract this, which I have to subtract both of them. So it turns out to be 2x squared, bring down the 7x. So now I have to multiply this by just x. Okay, so it's a positive x. And I'm going to say it gives me 2x squared plus 3x. Then I have to subtract it, so that goes away. And I'm looking at negative 10x plus 1. Now I got to multiply this by negative 5. Okay, and so that gives me negative 10x minus 15. And I have to add it, so do the opposites. Or sorry, subtract it, that gives me 16. That's my remainder. And so, kind of run out of room, but I'll write the final answer here. Remember, remainders are always plus this over the original divisor. Over the original divisor. Okay. All right.